Assalamualaikum warahmatullah and greetings to our respected lecturer, Madam Suryani Hassan. Today, both of us will present our finding in this mini project of subject ST00202 Basic Statistic for Semester 1 Session 2021-2022. Before we get started, the flow of our presentation is each of us will show an example of question and explain the solution of it, and then we will move on to the Q&A part. I'm Muhammad Osama Anas bin Muhammad Othman with student ID BS2111041. We'll start off our presentation and my finding and insight will focuses on hypothesis testing, specifically Z-test for a proportion. Without wasting any time, let's jump to my first slide. Here an example of question. A researcher claims that based on the information obtained from the Centers for Disease Control and Prevention, 17% of young people ages 2 until 19 are obese. To test this claim, she randomly selected 200 people ages 2 until 19 and found that 42 were obese. At level of significance equal to 0.05, is there enough evidence to reject the claim? Source of question comes from Elementary Statistic, a step-by-step approach, written by Ellen G. Blumen. Now let's check out the solution. The first step, we need to state the null and alternative hypothesis, and then we identify the claim. Based on the question given, there are 17% found obese, so the null hypothesis will be 0.05, which is the claim for this hypothesis. Meanwhile, the alternative hypothesis will be not equal to 0.17. What we can predict here, it is a two-tailed test since the equation equal and not equal. Move on to the second step. We need to find the critical value. Since the level of significance is equal to 0.05 and the test is two-tailed, from the T distribution table, the critical values are plus minus 1.96. Okay, we move on to the third step, which is we need to compute the test value. Here, we need to find the sample proportion, which is simply divided 42 over 200 to obtain 0.21. And then we substitute into the formula, we put P equal to 0.17 and Q we just subtract with 1 to obtain 0.83 and then plug in all the values. We calculate using calculator. We found the value of this in this step is 1.51. Move on to the fourth step. We need to make the decision. From here, do not reject the null hypothesis since the test value falls in the non-critical region. Refer from the bell-shaped graph above the 1.51, the test value fall into the non-critical region, so we can't reject the null hypothesis. What we can summarize here from the result, there is not enough evidence to reject the claim that 17% of young people ages 2 until 19 are obese. All in all, this type of question can be addressed through statistical hypothesis testing, which is a decision-making process for evaluating claims about a population. In hypothesis testing, the researcher must define the population under study, state the particular hypothesis that will be investigated, give the significance level, select a sample from the population, collect the data, perform the calculations required for the statistical test, and reach a conclusion. My references come from ebook of Elementary Statistics, a step-by-step approach written by Ellen G. Blumen, the 10th edition. That's all for my presentation. Do you have any question?
Yes, I have a question. I want to ask you, how do you obtain the critical value from the T distribution table?
Alright, what I have put here, the critical value equal to 1.96. So what we can do, simply refer to the distribution table, and here I have prepared the distribution table. Since it is a two-tailed test, we refer to its significance level, which is 0.05, and then the F here, which is stands for degree of freedom not given. So we treat it as Z value and found the critical value equal to 1.96. Just simply follow the arrow I have put here. Okay, that's all from me. We move on to the next presenter.
Okay, thank you, Anas, for giving me a chance to present my mini project presentation for uh, the subject basic statistic. Before I present my presentation, I will introduce myself. My name is Gabriel Dennis with my matrix number BS 21110402. As as I have done my mini project, so I want to present it to all of you. So, in my presentation, I have uh, state the problem of confidence interval. So, my presentation is focused to confidence interval, and the second one is the solution of the problem. Next. The problem of the confidence interval. There were 2,430 Major League Baseball (MLB) games played in 2009, and the home team won in 54.9% of the games. If we consider the game played in 2009 as a sample of all MLB games, find and interpret a 90% confidence interval for the proportion of games the home teams win in the Major League Baseball. Next. Okay, we look on the solution of the problem. To find a 90% confidence interval for P, the proportion of MLB games won by the home team, we use Z is equal to 1.645. Next. Next. Okay, as we can see, I found Z based on distribution table. So we look in T distribution table on confidence interval, which is 90% as stated in the problem, and we look at Z infinity. There were so Z is equal to 1.645. Back to the slide before. So we can see that Z is equal to 1.645 and P is equal to 0.549. Where I get P is equal to 0.549? It is from 54.9% that's stated in the problem. So we divide it by 100 and we will get 0.549. From the sample of N is equal to 2,430 games as stated in the problem. The confidence interval is sample statistic minus Z times with SE less than new less than sample statistic plus with Z times with SE. So we can see the formula is P minus Z times square root of P in bracket 1 minus P over N less than new less than P plus Z times with square root of P in bracket 1 minus P over N. So based on this formula, we can substitute all of the information that we gain from the problem into the formula. So by using calculator, uh, we should get the final answer is uh, 0.532 is less than nu less than 0.566. Where I uh, where I get 0.451, that is from 1 minus p. As we know, p is equal to 0.549. So 1 minus 0.549 is equal to 0.451. Next. Next. Okay. This is my reference. I get it from solution of homework 8, retrieved by this link. That's all from me. Have you has any question?
Yes, I have a question. From your solution slides, what's the meaning of SE?
Okay, SE is actually the short form of standard error. Okay, that's all from me, and uh, thank you for lending your ears for me. That's all from our presentation. Thank you.